resistors. One of them 4.7 kiloohm, and 3 of them 10 kiloohm. 2 NPN transistors BD139. 5-volt DC power supply. Finally, breadboard. Now we will start with NAND gate. Here is the truth table of it, and here is the electronic circuit. Let's start with putting our 2 NPN transistors. Now we will connect the collector pin of first transistor to positive terminal of our 5-volt DC power supply. After that, we will connect the emitter of the other transistor to ground through 4.7 kiloohm resistor. Now we will connect the emitter of the first transistor to the collector of the second transistor. Connect the 2 transistors' base terminals to 10 kiloohm resistors as you see in electronic circuit. We will use the white wire and red wire as switches by connecting them to a positive 5V voltage when experimenting. Connect our power supply terminals and let's start trying. We will measure the output on this resistor by using oscilloscope probe. Here is the truth table of NAND. Let's see if our circuit can achieve it. The first condition: when the 2 input A and B is 0, the output will be 0. As you see on oscilloscope, the output is 0. The second one: when B is 1 and A is 0, we will connect the white wire to positive terminal. As you see it, the output is still 0. The third condition: when A is 1 and B is 0, we will connect the red wire to positive terminal. As you see, the output is still 0. The last one: when A is 1 and B is 1, we will connect the 2 wires to positive terminal. As you see it, the output is changed to 1. As you see, we can achieve the truth table using this circuit, so it is correct. Now we will start to connect the circuit of NAND gate. Here is the difference between NAND gate circuit and NAND gate circuit. We will change the place of this resistor and the output point as you see in the video. Now we will change the place of resistor to make NAND circuit as you see in the video. Now we will put our oscilloscope probe to measure output. Here is the truth table of NAND gate. Let's see if our circuit achieves it. As you see, when A equals 0 and B equals 0, the output is 1. In the next 2 conditions in the truth table will give us the same output equals 1. When input A and input B are both equals 1, the output becomes 0 as you see on oscilloscope. As you see, we can achieve the truth table using this circuit, so it is correct.